let's put it all together. What we're going to have to do now is rewrite our function. I don't know why this brings up confusion always in the past year, so I'm going to kind of make things really, really clear. In the way we're doing our notation, you need to be clear with the notation. Let me show you what we mean. So we can't take the derivative of this. So the thing what we know that the derivative of x to the n currently is n times x to the n minus 1. This is currently all we know. That's what I meant by currently. So this is not of the form x to the n. This is 1 over x to the n. This formula does not work for 1 over x to the n. We need a different formula for that. But we can manipulate this so it looks like this. Well, how do you do that? Well, we rewrite it. So f of x currently, there I am with that word currently again, and you stop using it, is 1 over x to the 7. We're going to rewrite it. So I'm not going to call this f prime of x. We're not going to call it f prime of x until we do the derivative, which is bringing down the exponent. I'm not taking the exponent down or doing any of that. I'm not taking the derivative yet. I'm rewriting f so we can take the derivative. So I'm still calling it f. And this is what I mean, be picky with the notation. That's what's going to make or break you on these. So how do I write this? I bring that x to the 7 to the top, and now it's x to the negative 7. We could take the derivative of that. So now let me do it in a different color. This will be f prime of x. Now we're taking the derivative, and there's your answer. And then usually if you start in this form, it's going to be multiple choice most of the time. I think Khan will accept this answer, but it's a good habit to get it back to the form that it was in originally, because usually with multiple choice, that's what's going to happen. So I'm going to drop that x to the 8 to the bottom, and that would be your answer. Now note, because that's a negative over a positive, you could just put the negative out front and just say the overall fraction that we have there is negative. That's probably going to be more likely what you would see on the multiple choice. By the way, same thing. That example, exactly the same. Let's go through one with a radical. So this one, I'm going to rewrite it. So g of x, it doesn't currently have the form that we need, which is that x to the n, right? So can I write it as something as x to the n? Well, yeah. Power is 4, index is 3. Notice that right here. Power is 4, the index is 3. Now I can go ahead and find the derivative by bringing down the exponent and taking away 1. And like I said, it's a good habit to get into, to put it back into the form that it started in, which was the radical form. So this would be x to the power 1, so I won't put it, and then a cube root because the index is 3. And if you want to, that could be 4 cube root of x over 3 like this. Either way, both of those are the same. But I just want to make sure you're exposed to both those forms. I think the hardest part of this that students have is usually just seeing the different forms of the same thing. But like I said, I did it in different colors to make sure you're clear. This was just rewriting the original function. So our original function was cube root of x to the 4th. That's the original function. We just rewrote it here. Then in blue here, I did the derivative. That's when I put the prime. And I put this example just so you guys are clear that this has a index of 2. So when I'm taking this derivative, I'm still going to mark derivative notation. But when I rewrite it, it's x to the 5 over 2. So the index is 2. I know the index is missing. If it's missing, it's a 2. Then from there, we're going to get rid of the d dx when we take the derivative. Actually, I'll just keep it there like that. And then you should rewrite it, but I just want to show you how two things in this, that the index, if it's not there, is a 2. And the other thing is, when you do d dx, see how I rewrote it? I still kept the d dx there, so meaning I still need to take the derivative. And then once I've taken the derivative by bringing down the exponent and taking away 1, now that d dx is gone. Like I said, that notation is what's going to make or break you on this assignment. So you got to get used to it. The different forms in that notation, I don't know why that's where people struggle with, not so much the actual calculus part.